Welcome everyone. We're going to be doing the webinar on the SERH 4th edition, the Safety Equipment Reliability Handbook. If you have any questions throughout the webinar, there is a panel on your right-hand side. You can go ahead and type questions in that question bar. I am not the best at looking at them throughout the webinar, but I will make time at the end to go ahead and look at any questions and answer any questions you may have. So if you have any questions that might not have been answered throughout the webinar, just wait till the end and I'll make sure to get to them. You will also be receiving a printout of the slides and a link to the recording of this webinar if anyone that signed up for this. So if you want to look back at the slides or listen again to the webinar, you can do so, or you can always go to our YouTube channel or our website to do so. A little bit about me. I graduated from Virginia Tech with a BSME. I currently work at Exida, supporting the mechanical aspects of our customers. I work as a consulting and a safety engineer here. I also work on assessing the safety of products and certifications, and also research and publishing reports on stiction, on comparing failure rates, on the 2H initiative, and creating a database on that. A little bit about exida. Exida is an end-user consulting, accredited product certification and research firm with significant expertise in safety-critical and high availability automation systems, control system cybersecurity, alarm management, and process safety. Exida has performed more process control certification than any other company worldwide. We have main offices located in Sellersville, Pennsylvania, USA, and that's where I am, and also Munich, Germany. But we also have locations worldwide with services centers in Brazil, Canada, Mexico, the Netherlands, New Zealand, Singapore, Japan, South Africa, the UK, and we have a new one opened up in Abu Dhabi. And here's a little, I'm a visual person, so this helps me visually. As you can see, we're all over the world, so no matter where you or your customers are, we have someone close by that can help. A little bit about our main products and service categories. Whether it's a process, product, or people, we have a hand in all aspects of functional safety. We do consulting for IEC 61511, IEC 62061, and ISO 26262, alarm management, and control system security, or ISA S99. We have engineering tools such as Excellentia. We have FACS, SIL selection, LOPA-X, SRS, and SIL verification tools. The safety case tool, FAMIDA tool, SIL alarm, SIL stat, and CyberFax. We also have product certification. And that involves IEC 61508, control system cybersecurity, and network robustness. We have training. So if you want to come to us, if we want us to come to you online, it doesn't matter. We can train you with whether it's these webinars or actual more formalized training. We can help you out. We also have reference materials. We have database, tutorials, textbooks, reference book, market studies, white papers, blogs, webinars. We have a ton of reference material that we always try and get anything with functional safety, the message out there. And we have our professional certification. We have the CFSE and the CFSP certification. And we also have our automotive, our CACE or CACS, hardware, machinery, process, and software specialties in the CFSE and CFSP. A little more about our engineering tools. We have alarm management, PHA, SIL selection, SRS, SIL verification, proof test specification, and SIL stack, our data collection tool. But the main reason you came here today was to learn about the Safety Equipment Reliability Handbook, our SERH 4th edition. What is this SERH? Exida is very pleased to announce the latest release, which is the 4th edition of their failure rate book, the Safety Equipment Reliability Handbook. The book is a hard copy of Exida's SERH database that contains a vast amount of equipment item reliability data. The SERH provides a collection of failure rate data that is used in safety instrument system conceptual design verification in the process industry. The SERH remains the ultimate reference source for any safety engineer involved in conceptual design and safety integrity level verification. As you can see, it is broken down into 3 volumes. We have our sensors, volume 1, our logic solvers, volume and interface modules, volume 2, and our volume 3 is final elements. These are broken down into more specific and more specific details. So the sensors includes fire and gas, flame monitoring, flow, level, pressure, proximity, and temperature measurements. Our logic solver and interface modules include barriers, surge protective devices, relays, logic solvers, fire and gas systems, and solenoid drivers. And finally, we have our final element book, which includes solenoids and digital valve positioners, pneumatic interfaces such as quick exhaust valves, actuators, valves such as ball valves, butterfly valves, gate valves, etc., and gas pressure regulating valves. And the new edition has many new manufacturers, which we're really excited. And this actually takes our book to containing over 200 different OEMs. In the 12 years since the first edition was published, the number of equipment items with realistic failure rate data has increased tremendously. The new edition has many new manufacturers taking the book to over 200 different OEMs. The Safety Equipment Reliability Handbook remains the ultimate reference source for any safety engineer involved in conceptual design and SIL verification. Users of the data can trust that this data represented has been reviewed in detail and judged applicable for use to evaluate equipment items such in safety instrumented function applications. A person that we sent the book to review looked through it and was very excited about the new information that we have. He said with the SERH, the amount of time needed to research the individual products and to determine the applicability of the data to safety instrumented systems in the process industry virtually drops to 0. He continues, having a single source of failure rate data easily implemented by users, SIL verification calculations will improve effectiveness and consistency. So having this book be a new edition, I wanted to show you a couple of pages and examples from what you would find inside the book. A few examples I have taken are actually from the 3rd edition or the Final Elements book. And the first example we're going to look at is actually a actuator. So as you can see, we set up the table the same way each time. We start with the equipment type on the top, so you can filter by equipment type, and go through the general information, the manufacturer, the model, the hardware and software versions. Then we get it down into more detail. So what is the actuator type? Not just that it's an actuator. Give me more information. Then the actuator action, along with the architecture type and the hardware fault tolerance. And if there's internal fault detection time, that's given there also. Next, we look at if it is 61508 certified or not, and who it is certified by. And finally, we look at the SIL capability and what is it can be capable for. At the bottom, you get the meat of the information, the failure rate data. You can see how this particular actuator is evaluated for both normal and partial valve stroke tests. The failure rates are considered for both. You have your failure rates in your dangerous detected, dangerous undetected, safe undetected. Obviously, your enunciation, undetected and undetected don't matter for an actuator, but also your residual. Then you come down below that table and you can see if it is what the safe failure fraction would be for this instrument using route 1H, and if it is 2H compliant, which we will be talking about why that makes a difference later on. Finally, we look at the environmental profile, which we, once again, will talk about later on, and the useful life in years if it is a low demand mode application, and also in cycles if it is a high demand application. Next, we can look at a page of, and this one is the solenoid valve. So as you can see, it has the same general information. It gives you the manufacturer, the model, the hardware and software versions if there are any. The interface type, if it's analog or digital, the architecture type, and the hardware fault tolerance. Below that, you can see if it is assessed to 61508 certification or not, and whom it is assessed by, along with the SIL capability. You also have the failure rate data, how it was assessed, your different ways it was assessed, and different failure rates there. If it was assessed per route 1H with the safe failure fraction, or route 2H if it's compliant, the environmental profile, and the useful life. And here's an example of a ball valve. You have the manufacturer and model, the hardware version, the valve type, you get more information there. You come and get the seat type, architecture, it's architecture A or B type architecture, and your hardware assessment is later in time. Who it was assessed by, the SIL capability, and as you can see, the failure rate table looks a little different on this one. In valves, this one is broken up into a close-on trip or open-on trip application. And the close-on trip application actually gets even more specific for full stroke close-on trip or tight shut-off close-on trip. For each one of those scenarios, you have the normal conditions or conditions with partial valve stroke testing. As you can see, you have your, once again, your dangerous detected, dangerous undetected, safe undetected, and residual failure rates. But below that table, I want to show you that you have your safe failure fraction, route 1H, but you also have if it is route 2H compliant. And as you can see, this one is. So you have little check marks below that to let you know that in all 6 of these operating conditions, you have Route 2H acceptable. And once again, I'll explain more about Route 1H and Route 2H later on in the webinar. But I just wanted to show you what this looks like. You can also see the environmental profiles, which we'll talk about later, and the useful life here. Next, I want to go ahead and show you a little bit more of the sample page. I just wanted to show you the index here. So this doesn't have, the failure rates and everything that we just looked at, but this is the very, very back of the book that you can just see how much information is actually included in just the final elements book. This is book 3. And as you can see, we just keep going. So it's easy to believe here how there are 200 different OEMs taken into consideration for these new books. So I'm asked, who can SERH help? And that's a great question. First, we want to take a look at SIL verification customers. Why would this help anyone doing SIL verification? First of all, it will provide a quick and convenient data to use in calculations. It's effortless search of assessment levels and products to determine whether to do proven and use verifications. You can save hours of research for each product, providing data necessary for calculations for the process industry. You would avoid the use of unrealistic data resulting in very unsafe designs, and possibly even avoid expensive redesigns of systems after an independent functional safety assessment would be accomplished. If you did in fact use unrealistic data, or if it wasn't quite what, or the numbers weren't correct in your calculations. Also, conceptual design and instrumental engineers can also be helped by the SERH. Since it is a convenient equipment selection, it saves time not having to conduct research in which items have already been evaluated for functional safety. It would have a quick and convenient data at your fingertips to use in calculations. Effortless search of assessment levels in products to determine whether to do proven and use verifications. You can save hours of research for each product, providing data for necessary calculations for the process industry. You can avoid the use of unrealistic data resulting in unsafe designs, and possibly avoid the expensive redesign of a system after an independent functional safety assessment is accomplished. So no matter who you are, you can save a ton of time and ultimately a ton of money using already done research for you. It's an easy tool to use, and it provides you saving a ton of time and money. You don't have to do the research yourself. It's already done for you. Let's talk about some key features and benefits. So the failure data specific for safety instrumented systems, designs, and verification are done for precise calculations. Comprehensive data from FMEDA results include failure rates, which we saw on the sample pages, useful life, certification status, and SIL capability, which we saw all of that on the sample pages. That enables an all-inclusive level of detail and analysis, along with advanced modeling tools such as Excellentia that will permit the customer or you to investigate what type of coverage is expected and what credit can be claimed for safety instrument and functions. That's huge. Numerous different manufacturers and equipments from more than 200 OEMs, enabling quick and easy searches for certified functional safety products, accurate and precise data for specific manufacturers, and product based on detailed analysis of products by the exida predictive analysis qualifying accurate failure rates and data for precise calculations. And it is the only product-specific reliability data source on the market. This allows you to save hours of research while reviewing the largest collection of data available. So what does the SERH encompass? It's an expansive collection of equipment items comprised of FMEDA results for, as we spoke, sensors. Volume 1 is the sensors, Volume 2 is the logic solver and interface modules, and Volume 3 is all of the final elements. What we're really proud to kind of brag about is the collection of equipment items features over 100 different pressure measurement devices, over 100 different level measurement devices, over 90 different fire and gas devices, over 50 different temperature devices, over 200 different input interface modules, over 100 different output interface modules. We have over 30 different PLCs, over 30 different limited function system and relays, over 200 different valves, over 100 different actuators, and over 150 different final element interfaces, which most people call solenoids. Now you may ask, well, I have the 3rd edition or the 2nd edition. Why should I upgrade to the 4th edition? Well, the collection of equipment items have vastly increased since the 3rd edition. We have new manufacturers and several new devices. For example, the 4th edition, as I've already bragged, includes over 200 unique valves. And this has actually increased from just 20 in the 3rd edition. That's huge. The products have been reanalyzed and/or new versions have been included of these products. And additional information is listed. That includes if it's Route 1H or Route 2H, the environmental profiles, the internal fault detection time, if applicable, and the applicable hardware and software versions. So to give you background information on the new information included, we're going to start with architectural constraints from FMEDAs, or Route 1H or Route 2H. This is straight from IEC 61508. As you can see, there's 2 options you have from certifying through architectural constraints. Route 1H is the safe failure fraction. So that takes, and this is the safe failure fraction of the 2010 edition, which changed from previous edition. You have all of your safe failures over all of your safe plus dangerous failures, giving you a percentage, and that's your safe failure fraction. Or the 2010 edition introduced Route 2H. Because they changed the calculation, they had to give they had to make a different way for simple mechanical devices to be evaluated. In comes Route 2H, and this is the assessment of reliability data for the entire element according to IEC 61508. Taking a closer look at this Route 2H is based on component reliability data from feedback from end users, increased confidence levels, and hardware fault tolerance for a specified safety integrity level. So it's basically looking at if this has been proven in use. Has this technique or have these parts been in the industry and know that it can work in the industry? So when it is classified Route 1H or Route 2H, you now can look up if you have other parts of your system classified route 2H and want a 2H in valve or actuator. You can go ahead and look up what you were going to use or what is 2H, and you can make your determination from that. Exida has a very extensive 2H database, and it summarizes all the data collected to date through the assessment. So whatever has over 1 billion or more hours on the mechanical databases, it gets checked that that part is qualified as 2H, that component. And we have more than 50% of the components on the mechanical database checked as 2H. And our database totals over 100 billion operating hours collected. As you can see, this is a little snapshot from our database, and we are zeroing in on the subtype of component of a ball valve. You can see each failure mode is broken out for each part of the ball valve. And if in the total hours, if it does have over 1 billion hours accounted for, you get your little check mark. And when doing an FMEDA, if all of the components receive that 2H check mark, the entire device can be rated 2H. The next portion that's new is the environmental profiles. As you can see, the 3 examples that we thought of, or that I showed you earlier, were actually all environmental profile 3. Exida has divided up atmospheres into 6 different categories. Profile 1 is cabinet mounted and climate controlled. Profile 2 is low power field mounted, no self-heating. Profile 3 is general field mounted, self-heating. Profile 4 is subsea. Profile 5 is offshore. And Profile 6 is process wetted. Each product is evaluated at the appropriate environment, which is listed in the SERH along with the description and the conditions for each profile. And that wraps up most of the detail on the 4th edition of the SERH. But you can also see any other additional reference material that Exida has on our site, exida.com. And here are some links that I wanted to make available for you. First of all, at the very top, I have my email address. If you need any information on the SERH or any questions in general, feel free to email me. Below that, you can get more information on just the SERH or anything Exida does at our website. Underneath that, that is the link where you can purchase the SERH. Or link with that, the SERH handbook at this link. Or you can receive the download the flyer. Or you can also download the sample pages, some of which I showed you, the index and a couple of the pages on the inside, to get a better understanding of what is going on in the handbook itself. So if you have need any more information, I would definitely suggest that you look at that. And if anybody has any questions, I'll of course forgot to look through them. I will look through them now. Hold on one second. The first question I had said that the last sentence is lost on the bottom of the pages. It might be a syntax window problem. If you indeed were not able to see the bottom of the slides, don't worry, you will be getting a copy of the slides, so you can go ahead and see. That will probably be later this week or early next week sent out to you. The next question talks about working in the machinery sector. Can the SERH data be readily used under IEC 62061 or ISO 13849, or is there some conversion needed for the data? To be quite honest, I do not work in the machinery section, but if you would like to, I can ask my colleagues who do work with IEC 62061 and get that answer for you. If it's something that you'd like to know, send me an email and I will make sure I have a colleague email you back with those answers. The next question is discussing the profile categories. How, what about the cold field condition? In our environmental profiles, we do have considerations. The general field mounted profile 3 does go quite cold. We do have temperature ranges for each profile, such as subsea also does get quite cold. This is also explained in the book with the temperature ranges. It also talks how if there's vibration to look at or anything else, they have all of the different ranges included in the environmental profile table. The next question is, the 2H initiative, I noticed, depends on end user feedback, but very rarely the end user turns in a failure data, hence is the 2H data reliable? The 2H data is reliable. We understand that end users don't always return in failure data. Every time we do an evaluation of a product, we ask for all of their shipments and all of their returns, and we have been collecting those. And we also look at the complexity of a project. If it is a simple project or maybe a cheaper device in a large system, we take into consideration that probably only 20 or 30% of the returns would be recorded. If it is a high dollar or a very complex piece of machinery, that would be up that percentage. So we definitely take that into consideration. And since it is a database that we have, I think we're almost up to 200 billion operating hours at this point, and each component only needs 1 billion operating hours. We definitely have a high margin of safety on the 2H. I would definitely, if you're doing something that is going to be 2H, I would look into how complex and how deep the company doing the evaluation is looking into that initiative. And I would definitely, if somebody just said, oh yeah, sure, it's proven in use, challenge it. I tell everybody, all engineers I meet, to always challenge things. And if someone's just telling you to accept that they are correct, especially challenge them. So if you are coming into something that is 2H, challenge it. Challenge how much data was collected. Say that you want to know the numbers and everything like that. The next question was a follow-up. It's in general, which is conservative, route 1H or route 2H? Both can be considered conservative. The main difference is that route 1H can deal with every device, and route 2H, because simple mechanical devices do not have necessarily diagnostics, a valve would have a safe failure fraction of 0. So you might not be able to have a route 1H in a simple mechanical device. So I would look into, depending on what type of device you're looking at, look into both options. Both can be very conservative if the company is conservative company that you're working with. If the company doing the evaluations is not conservative, it might not be a conservative approach. So, like I said, do your research, know who you're working with. The next question has the online SERH that comes with the ultimate server license for Excellentia be updated, and will it include the new information you presented? Yes, it has been updated, and it, I believe, includes all of the new information. I'm not sure. I can double check and get that answered for you. I have just been working on the book side of things. I know that it is updated with the new devices and new failure rates, absolutely. I'm not sure if it now shows the environmental profiles or the 1H or 2H architectural constraints. So I would tell you to look in and play with it, but they absolutely have the new products, the new devices, the new OEMs, and the failure rates. So definitely, if you have your Excellentia server license, always use that. It's a great wealth of information. If anybody has any more questions, please let me know and email me, and I hope everybody has a wonderful evening.